This video brought to you by the Original Forceman. So we're going to do Gaussian elimination from top to finish. And then we're going to answer the question, are these things consistent and are they independent? So I think the first thing I'm going to do is rewrite each equation in a vertical fashion, lining up the x's and y's and z's. And then we're going to pick two equations and do elimination on them and eliminate either the x's and the y's. Now, you're going to see that this is a huge shortcut. If we look at these two equations, we have opposite y's and opposite z's. So all we have to do is add these two together, and we immediately eliminate two variables. So it skips from doing from getting a 3-variable down to a 2-variable equation and gets us immediately down to a 1-variable equation. So here we go. Add these two together. Y's disappear, z's disappear. 1 plus 4 is 5x, and 11 plus 4 is 15. And then we get that x equals 3. Now, we can take any other two pair we want and plug this 3 in for the x to get one of the other two. So what I'm going to do is I'm just going to take, I'm going to take these next two, and I'm going to rewrite them with an x, with the x in there, and then we're going to either solve for y or z. Now, having gotten x right away, it skips having to do this twice. So we'll do 4 times 3 plus 2y minus 3z equals 4. That's this equation with x in it. And 3 times 3 plus 3y minus z equals 4 as well. Now, note that 4 times 3 is 12, and 3 times 3 is 9. So I'm going to subtract those over to the other side, and I'm going to rewrite this whole thing here before I try to do any kind of elimination yet. So I got 2y minus 3z equals 4 minus 12. That's a negative 8. And then I got 3y minus z equals 9, or 4 minus 9. That's a negative 5. Okay, so now we have a familiar problem, and that is, let's just eliminate on this. And I'm going to suggest we multiply this second equation by negative 3, and then we'll have opposites here for the z's. So I'll rewrite the first equation, 2y minus 3z equals negative 8. And I'll rewrite the second equation being multiplied by the constant negative 3. So here's negative 9y plus 3z equals 15. Let's add this, and we'll immediately get a solution for z. So goodbye that one. We get negative 7y equals, oh, wonderful, right? Negative 7. So we get this nice integer solution. This was a contrived problem for sure. Y equals 1. So we have 2 of the 3 parts. Now all we have to do is take the x and the y and plug it into any one of these 3. I'm going to start with the first one, just because, why not? So we'll have 3 minus 2 times 1 plus 3z equals 11. You know, I should have done the last one because then I wouldn't have to divide at the very end, but whatever. It's all the same, right? Let's see. 3 minus 2, last I checked, was 1. 11 minus 1, last I checked, was 10. And so z equals 10/3. All right. Yeah, I think that's right. So here's our final solution. 3, 1, 10/3. Wonderful. So now to answer the question, are these equations consistent? And they are, because there's at least one solution. And are they independent? And they are, because each equation is its own plane. There is no overlapping, no equation that is simply a multiple of some number.